Yeah, like you said, I'm Jaren, and today I'm talking about Kafka. And yeah, the small team was basically for a large percentage of the last 3.5 years, just me, and then we have a new guy, Harry, who joined the team. So we're gonna talk about that. How's that sound? All right. So the name of the talk is Tackling Kafka with a Small Team. Ooh. So my name is Jaren Glover. I'm an early engineer at Robinhood. I spent the last 3.5 years scaling their infrastructure there. I'm originally from Louisiana, and I like to describe myself to my friends as someone who cares a lot about software, economics, and culture. So that means that if you want to talk about distributed systems, interest rates, or DMX's first 2 albums, I'm your guy. All right? That's my Twitter handle and also my GitHub handle if you want to see the hot takes on the internet. Cool. So I work for Robinhood. Robinhood's mission is to democratize access to the financial markets. In doing so, we saved over $1 billion in commission fees for our over 6 million customers, and that excites me. And as you can tell, we have really great designers because that's the best slide in the deck. But yeah, it's exciting, so exciting, especially if you kind of think about the Venn diagram that I talked about earlier. I just love getting high quality financial products into our customers' hands. But enough about me and enough about Kafka. Not enough about Kafka. Enough about me and enough about Robinhood. Let's set the stage for this presentation. This isn't a presentation about how easy it is to scale Kafka or a presentation about how Robinhood's engineering organization is deploying and leveraging event-driven architecture better than the next startup. No, this is about an engineer's journey to keep Kafka stable in an extremely nebulous and dynamic environment, despite flawed assumptions and a steep learning curve. And I'm not here to be the authoritative answer on small teams in Kafka, but to provide context and perspectives and hope that my headwinds will be your tailwinds, okay? So specifically, we're gonna talk about how Robinhood's organization evolution and engineering trade-offs had created tailwinds for scaling a complex system like Kafka. How's that sound? All right. So sweet, let's start off in talking about Robinhood's organization. But first, let's hop in our DeLorean and go back to 2015. What were the engineering organization driving forces that led us to deploy our first distributed systems, right? We already were providing commission-free trading to our customers. We had product market fit. Why introduce this complexity? Well, we needed a system that would allow us to do 2 things. The first one being, we wanted to decouple our product analytics from our monolithic Django app. Next, we wanted a system that we could build an event pipeline on top of. We had amazing data engineers, and we wanted to build our own event pipeline versus outsourcing it to a third party. All right? But like most things, like Kafka was great. It's easy for, given those 2 problem statements, you can easily come to the conclusion that Kafka should be the obvious answer, right? We had a ton of respect for Neha, Jay, and June, right? The infrastructure that they built at LinkedIn was pretty amazing. But we did have some concerns, right? During this time, Kafka 0.8 had just been released. And during that time, we had the Jepson analysis that came out. The Jepson analysis, for those that are not familiar, is this amazing open source analysis done by a dude on the internet called Afer. And what he did with Jepson, he's built a great process for structurally analyzing distributed systems to verify the claims that they have on the internet, right? So he's built a process to verify those claims, which is pretty important if you're going to build the back of your event-driven pipeline on top of the system, right? So we deployed Kafka, like Kafka 1 in the cage maps of distributed systems, Kafka 1, right? Everything was good in life, right? We deployed it in like a corner of the VPC. It wasn't critical path. I repeat, it was not critical path. It was an experimental system. But I work at an extremely fast-growing company, and life comes at you fast, right? For better or worse, Kafka was this kind of experimental system that quickly became critical, what seemed like overnight. So now the question is, how did it become critical overnight, right? Did someone tell you? No, right? They got the taste of stream processing and they loved it, right? So with the benefit of hindsight, I can kind of unpack 3 of the main areas that drove it to being critical so fast, right? The first one being, our executives wanted to make real-time business decisions with real-time data, right? It's really hard to do that if the data isn't actually real-time, right? The market opens at 6:30 on market trading days, and then our executives want to understand how our systems were evolving at 6:31, 6:32, and through the rest of the period of the market trading day, right? Next, our product managers were evolving their organization, right? We had built a great product, but we had ambitions of building more products for our customers, right? So our product managers wanted to run experiments to better understand how our new products could better delight our customers, right? They wanted to introduce data into their product making process. And lastly, my application engineers wanted visibility to their application, right? They wanted to understand what was going on before deploy, after deploy, and during the deploy. Well, I guess that's before deploy, during the deploy, and after the deploy. And if your system isn't providing real-time data, it's really hard to understand what the CPU or memory freeze is looking like over that journey, right? So now everyone agrees Kafka is this critical part of our infrastructure, right? Then the natural next question is what? Well, people started asking, is Kafka down, right? So on the left, you'll see I'm the Spider-Man on the left who's being like, I don't know, bro. Is it down? I don't know. And the application engineer is asking me, bro, I think Kafka's down. I don't know. Or is it down? All right? So as you kind of see here, there's two distinct perspectives here. You have the application engineer's perspective, and then you have the infrastructure engineer's perspective. And we'll dive in and unpack why were these two perspectives so different between the two individual engineers. And we'll start off first talking about the application engineer's perspective. So the application engineer had this implicit trust of Kafka, right? It was simple, it was magical, right? You produce an event, you consume an event, and because of the replication factor of 3, there would be no data loss, right? That's why we chose Kafka, and this was why why Kafka was the business on the internet, right? But this implicit trust led to this interesting behavior of not accounting for failure modes. For example, things like retry logic, right? What happens if the network is temporarily unavailable, right? What happens if you increase the number of partitions in your topic, right? Do you care about ordering? Is it okay if you get an event that was produced earlier than another event? How does that impact, right? Is your consumer actions actually idempotent? So those are the things that our application engineer had really thought about. Next, library ownership. So this is interesting. From their perspective, to provide some context, what is a library ownership? Here I'm talking about the library that you implement to produce, to create your own producer and consumer, right? This is a library that actually does that. And from their perspective, right, that wasn't their job. Right, their job was to build low latency microservices and build features for the product team, right? This library was kind of the infrastructure engineer's perspective. Obviously, I disagreed. So let's talk about my perspective on this topic, all right? So I was suffering from success. I did not understand the appetite for real-time data, right? Every new week, I had a new engineer that was producing a new form of data and consuming it in a new way I had never heard of, right? And every week, the amount of data that was being produced was becoming more and more critical for the organization, right? So I played myself, right? I did not anticipate how important this data would become, this data system would become inside of the engineering organization. Next, the problem with the kind of Spider-Man meme of Kafka down, right? I was playing technical whack-a-mole, right? I could not easily identify whether or not it was Zookeeper causing trouble, Kafka causing trouble, right? Or Kafka causing Zookeeper trouble, or vice versa, right? Because I didn't have the proper visibility to evaluate the health of the system. And the reason why I couldn't evaluate health, right, was because I didn't have my dashboards. It wasn't easy for me to identify and understand whether or not Kafka was actually down or Zookeeper was down, right? What was happening was I was opening up a tmux section with 6 screens and running 10 different commands across Kafka to try to evaluate health. Then I would open up another tmux section with 3 windows and run another 3 commands across Zookeeper to try to analyze whether or not Zookeeper was down. 20 minutes later, I would come back and be like, ha, Kafka's not down, right? But they were like, bro, what you mean? Like you expect me to trust you? So which is fair, but because I didn't have this ability to self-service for the application engineers, the burden of proof was on me and the team. And I have my own library ownership problem also, right? I don't write code, right? I'm thinking in my head, my job is to make sure Kafka is reliable. It has the ability to account for the capacity planning, that the data growth, and that the APIs inside of the infrastructure had low latency, right? And to me, that library felt a lot software-y. I was like, oh, cool, man. You can write Django code or Python code for your Django app. You can write code for this client library, and the responsibility is on you because I'm drowning, because I'm not only responsible for Kafka, but I'm also responsible for Zookeeper, Consul, Elasticsearch, and all these other systems, right? But nonetheless, so you can kind of see here, this is how our Robinhood's organization evolution kind of created these interesting frictions inside our environment. So next, we're going to talk about the engineering trade-offs. So the engineering trade-offs, conventional wisdom says this, right? You should automate and build tooling to automate yourself, right, to be able to scale your organization. In fact, I remember a great conversation I had with my co-founder where he told me, he said, Jaren, listen, if you automate yourself out of a job, we'll find something else important for you to do, right? And I was like, yeah, that's a great rally cry, but in practice, it's very difficult to achieve, right? Why? Well, the problem is when you have n-squared problems, but only n engineers, it becomes very difficult for you to be able to kind of see the forest for the trees, right? Which is fair, right? But nonetheless, you have to build tooling eventually. And so what we're going to talk about is how the things that we did well in the onset, the things we eventually did well, and things I hope to do well before the end of the year, okay? How's that sound? Woo! And this is a tweet, right? This is like my favorite thing that I always say, right? Hire everyone in high growth mode. Most things are easier tweeted than automated, which is true, right? It's very difficult to automate things when you're just drowning, just trying to focus on keeping your services up for the next day. So what did we get right? So the very first thing that we did right was we built a zero-touch process for replacing unhealthy brokers, right? So the question is, why are these brokers unhealthy, right? That's a great question. Well, because Jeff Bezos might have told me that they're unhealthy, right? Sometimes I would get these emails from my cloud provider, which is AWS in this case, that AWS is going to retire a broker, right? In this case, you can kind of think of broker and host to be interchangeable, right? Because we run our Kafka processes on individual EC2 instances. I would get these emails, and I would call my wife and say, well, babe, I'm not gonna make it home tonight till real late. I gotta spend all night trying to, with my surgeon gloves and trying to figure out how to replace this unhealthy broker. Or it could be because AWS sent me this email, or because me as the infrastructure owner might have made some changes to the JVM or to the kernel or something to that kind of made the host become unavailable, right? In the land of pits versus cattle, you have to kind of be able to evaluate, or just generally need to be able to replace unhealthy hosts in a stateful service like Kafka. But why is replacing unhealthy hosts so difficult, right? In my Elasticsearch cluster, all I have to do is increase the number of the number of nodes in my auto-scaling group. But for Kafka, it isn't that easy, right? The reason why it isn't so easy is because in Kafka, you have these broker IDs, and each broker inside your cluster has to have a unique broker ID. So that means, for example, if we take broker ID number 2, 102412, right? If we decide to replace that broker, right, and churn that host, whether it be through the AWS console or through AWS deciding to kill the particular broker, right, we want the next broker that comes from that auto-scaling group to obtain that broker ID number 2, because this ensures that the data will be replicated, right? Because we need, in order for us to maintain the guarantees of Kafka, right, at least in our infrastructure, we need, we have a replication factor of 3. So what we want to do, we want to be able to terminate that host, and we want that the next host that comes up from that auto-scaling group to be predictably be able to manage the broker IDs and obtain that broker ID number 2. Right? So what we did was we built tooling to automate this process, which was pretty great. It was pretty exciting, quite honestly, because I was spending a large amounts of my time just manually kind of dissecting, moving data around in the Kafka cluster in a very non-pragmatic way, which isn't good. Plus, my wife didn't like me staying, coming home so late so often. But nonetheless, right, we built this really great tooling that was built on top of Console, our configuration management tool, and it was a part of the bootstrapping process. And if anyone's interested in that, we can talk about that a little bit later in details. It was like my first real automation I ever did. I'm pretty excited about it, quite frankly. But we didn't immediately continue to automating, right? I was being drowned by these other tasks inside the environment, and we didn't continue. But recently we did something that was really smart, which was we built tooling for rolling restarts. So a rolling restart, or at least a safe rolling restart in the Kafka world inside of our infrastructure kind of meant this. It meant that you would restart the Kafka process for each broker inside your Kafka cluster one by one, right? So when you have a small cluster, doing rolling restarts are pretty easy, right? It's like you got 4 nodes in your Kafka cluster, restarting the Kafka process on each of those Kafka processes is pretty easy, right? You just open up your tmux session, SSH into the host, right? Do a Kafka process restart on each of those hosts one by one, 10 minutes max, right? And just provide you some context, the reason why you would be doing these Kafka process restarts or these rolling restarts a lot of times, because there's a ton of knobs on your underlying Kafka infrastructure. And in order to kind of apply these changes into your entire cluster, you have to do a Kafka process restart across all your nodes. So like I said, when you have a 4 or 6 node Kafka cluster, this is cool, this is manageable, right? But the moment you go from like 4 node cluster to a 9 node cluster or 100 node clusters, which we had at the end of last year, right? This becomes just unmanageable, right? This becomes really unrealistic for you to log in to 100 different hosts and do a Kafka process restart, right? Trust me, someone on my team actually tried to do it. But this was interesting because this actually created bad behaviors, right? We started having a lot of technical debt that would build up because we would say, hey, we need to make these changes to the underlying Kafka brokers, right? For example, we might want to increase the number of network threads or the number of IO threads that are available for the Kafka process, but we'll wait, right? We'll wait until we actually have some tooling to actually roll these systems out because there's no way we can do it. And whatever happened, like what happened over time is that this bad behavior kind of built up where we had these queue of changes, no pun intended, that would kind of build up that we were being blocked on this Kafka tooling restart. But thankfully, we eventually did it with some help of some of the members that recently joined my team, or the team that I work on. So thanks to Prometheus and Fabric. So Fabric is this really amazing Python library that allows for you to run arbitrary commands across remote hosts. And Prometheus is our monitoring system that also exposes a great API. Because we use Prometheus to monitor our entire cluster, right, we can ask questions about the health of our cluster through the Prometheus API in order to deem health. So here we have some pseudocode, which really isn't pseudocode because it's kind of the main function for the restart service inside our Fabric script. And let's walk through that, right? Pretty simple. So first, we query the Prometheus API to try to identify the cluster health, right? In our case, the health basically means a few things, right? Do you have a controller? Do you have no under-replicated partitions, right? And if you have these 2 things, then we deem the cluster to be healthy. Then we do a query to Zookeeper and ask, what are all the hosts inside this cluster, right? And the function returns back. And the cool thing about this, we actually do an ordering where we identify the controller and do the controller last. So we get this list of IPs, and using Fabric, we SSH and basically we SSH and run a command to do a Kafka process restart. We do that. The Kafka process restarts, we have under-replicated partitions, then eventually, assuming you have a healthy cluster, this cluster will become healthy, ideally with no human interference, and then it waits some period of time. In our cluster, we wait 5 to 7 minutes, and then it does another health check, right? Is the cluster fully healthy? And then if it's fully healthy, it continues to go into the next node inside the list of IPs, which this is pretty important because the moment we had this kind of evolved my velocity inside of our infrastructure. It did for one thing, it allowed me to manage multiple clusters. Before we had this tooling, I was like the old man yelling at the cloud. I was like, no more clusters. I'm having a hard time already just keeping this one cluster being healthy. So no more clusters, right? Then now that I have this new tooling, now I'm rolling out more changes more often, right? Because now we have more than one cluster, and the criticality of these clusters are split. So I can roll out changes to one cluster, make sure that let them bake for a couple days. And then I can roll it out to this more critical cluster, and that way I have this continuous flow of changes, and my underlying infrastructure is evolving because the underlying data that's coming into these clusters is constantly changing and evolving. So I want to make sure that my underlying Kafka cluster is being tuned, because trust me, there's a ton of knobs to tune, right? In order to get your cluster to be healthy, for better or worse, right? And you want to be able to roll these out, and you want to be able to roll these out where you go get a beer or coffee, right? So usually I try to roll these changes out around 5 p.m. after the market closes. So that's tooling. And this became pretty cool because now I'm about to spin up another cluster for the market data team. Our clusters are pretty big. I think we take in roughly, 80 terabytes a week to each cluster and kind of consume out about 100 terabytes a week. And they run some of the most critical things inside our system, which is pretty exciting. And effectively today, not everyone, I think every host inside of our VPC actually does some type of producing or consuming. And our application engineers have the trust of Kafka that they're willing to build more and more of their workflows on top of it. Next, soon to be right. So this we actually don't have right today, but thanks to a new member who joined my team by the name of Harry, there's a ton of work that's going into this. And I think this is the next function that we need to do. Oh, I need to pay for some software. Sorry about that. Oh, that's awkward. Now I have to buy it now. Now I feel like a lame if I don't buy it. Jeez Louise. Anyway, jeez, free promo. Anyway, what was that? Okay, soon to be right? So we need to overhaul the library, right? So we talked about it earlier when we talked about the Spider-Man meme, right? We had two individuals or two perspectives, and fundamentally what that meant was that our library, our client library was in purgatory, right? It wasn't evolving, right? Our application engineers are building more features, more quicker. I'm scaling our capacity, but our underlying client library is just in purgatory. And this becomes a problem because the biggest thing that I learned while scaling Kafka is that you want to make sure that you're tuning and evolving your underlying infrastructure, but if your library isn't evolving, you're going to find yourself in a bad news bears, right? Because it turns out that there's just as many knobs on the Kafka cluster as it is on the clients that we're producing and consuming. So understanding that becomes pretty important. You kind of want to take the Apple approach of being a full stack, where you want to make sure that you have high quality client library and a high quality configuration on your Kafka cluster. Otherwise, if any one of those two are out of whack, you're gonna have bad experience, and people are gonna be asking you why your Kafka cluster isn't down. But nonetheless, what we want to do is right now we're a Python and Go shop. So now the problem we were having was that we would have 6 new engineers that would join our engineering organization, and they would implement their producers and consumers in 6 different ways, right? And this was becoming a problem. And they were all asking me the same question over and over. All right, what do these flags mean? Does this matter? I don't really understand this. I never learned Kafka before. So here, I think that this is really a go where shared library can really kind of up the win for our engineering organization. So here we want to be able to reduce the choices in how a producer and consumer gets implemented in the 2 primary languages that we're going to support, Python and Go. So our plan is to build a shared library in Python and Go that kind of out of the box, no matter if you've been at the company for 6 years or 60 days, right? You have the ability to implement a Python consumer and a Python producer with relatively easy work, and you get a lot of these things for free. So that when bugs happen, at least they happen to all the consumers and producers, and they become a little bit easier to identify. Next, I want to provide my application engineers observability for free, right? So what this means, I want them to be able to capture exceptions via Sentry. I want them to be able to instrument their code using StatsD where it makes sense. I want them to be able to have same application logging. And then finally, the underlying library for all consumers and producer in Kafka land is something called librd Kafka that has an amazing set of statistics. And we want to be able to extract those out. And I don't want the application engineer to focus on that. I want them to be able to come in, writer, producer, and consumer, and get all this observability for free. And then finally, we have integration and regression testing. This is what I'm pretty excited about. My hope is that the way that I kind of approach changes in my Kafka infrastructure is that I deploy these changes in dev, then staging, and then production. And I have alerting and monitoring set up in place that would tell me if there's any regression here. I want to kind of apply that same logic to the underlying library, right? I want to be able to, there's a lot of community work that goes into these libraries, and I want to be able to upgrade those and get those kind of benefits as quickly as possible, but testing them, because the moment we move to a shared library for all of these, for our Python and Go clients, if we introduce a bad bug, that potentially could impact all of our producers and consumers at one time, and we want to be smart about that. So we want to try to reduce that risk over time by kind of having integration and regression testing that's automated. And then finally, I just would say that you can do it too, right? I'm convinced that, I'm not convinced that having a small team is the right thing to approach this problem, but I do think that if you tackle this process and understand how your organization evolves and think about these 3 core problems, I'm convinced that you can be twice as successful, have twice as many headaches, and do it twice as fast. And my name is Jaren Glover, and cool, thanks.